Good morning, friends. Today we will learn about depth-first search in binary search trees. Unlike arrays or stacks or queues, trees have various ways of traversing through them. Like in stacks, arrays, or queues, you have only one method, which is linear traversal, and you visit all the nodes. But in binary search trees or in trees in general, there are various ways in which we can visit each node. So let's look at a particular way of visiting nodes, which is depth first search. Depth first search is of three categories in binary search trees: in order traversal, pre order traversal, or post order traversal. In order traversal, we visit the left node, then the right node. Similarly, in pre order, we visit the node, the left node, and then the right node. And post order, we visit the left node, the right node, then the node itself or the root node. So let's look at the algorithm for in order traversal. So in order traversal, we first traverse the left subtree, then we visit the root, then we traverse the right subtree. For example, consider this tree given here. So its in order traversal will be, we go to the root, we traverse the left tree, then we go to this node, and for this node we first traverse the left subtree as well, then we go to this node, we traverse the left subtree, and then we go here. As there is no left subtree, we print 10 or we store 10, then we go back to this node. As there is, then we store it, and then as there is no right subtree, we go back to 30. Now we store 30. As there is no right tree, we go to 50, we store 50. Then we go to its right subtree. As you can see, first we traverse the left subtree of all the nodes. We traverse the left subtree of 50, then the left subtree of 30, then the left subtree of 20. And then we visit that node, and then we traverse the right subtree. So as we visited 50, now we will traverse its right subtree. So we visit here, we get to 100. Now we traverse its left subtree. We go to 70. So we store 70. Then we go to the node itself, which was 100. And then we traverse its right subtree, which is 120. And as it has no left subtree or right subtree, we just store 120. And there we go. This is the in order traversal of the binary search tree. As you can see, we get the result as sorted. So it is a way of getting the sorted numbers from a given binary search tree. This happens in order n as we visit each node once, where n being the number of nodes. Now let's look at pre-order traversal. Pre-order traversal is also a similar type of traversal, just it's slightly modified. So let's look at its algorithm. In pre-order traversal, we first store the root, then we traverse the left subtree, and then we traverse the right subtree. So let's take a look at this example. We go to the root 50, we store 50, then we traverse the left subtree. We go to 30, as we similarly call pre-order at 30 as well. We store the root, which is 30, so we store 30, and then we go to 20. Then we call pre-order again, we store 20, go to its left subtree, 10. As now we have traversed the root and the right subtree, we go back, check if there is a right subtree, there is no right subtree, go back till 50. Now we traverse the right subtree. So first, as we first print root or store root, so we get root after 100 after 10. Then we go traverse the left subtree, which is 70, and then we traverse 100's right subtree, which is 120. So this is the answer of the pre-order traversal of this given binary search tree. Now let's look at its post-order traversal. Post-order traversal also follows a similar structure. So post-order traversal, we have traverse the left subtree, traverse the right subtree, and then store the root. So let's look at this example. We